Okay, hello and welcome to week 8. So hopefully you've just turned in your breakout exercises, which I'm hoping was an enjoyable one. It's a chance for you to flex your creative muscles a little bit, do something cool. I should also mention you probably haven't received the mark for the spaceship exercise yet. Don't worry about that. It's just that the TA was had some personal things to deal with last week and was busy and had to mark a midterm and lots of stuff. So she's a bit behind, but we'll be catching up hopefully over the next couple of days. So we're going to try and get all that sorted out, but it's not something you need to worry about. There's been a little bit of drama here. As you may recall, last week the speakers weren't working and I had to get tech support out to try and fix it, which they singularly failed to do. So I had to call them up again this morning, and they also, they were unable to attend, but luckily I figured it out myself while I was talking to them. So I think we've got audio, which is good because I need it for some of what we're doing today. Also, my bike is broken. I got my bike out to come here and discovered the back tyre is completely flat. I don't know whether someone's let the air out of it or whether it's got a puncture. So I had to run here later than my usual time, which is why I'm sweating like a pig. So that's maybe more information than you really needed, but now I've recorded it as well, so here we go. Right, what are we doing today? I don't know. Oh yeah, something about objects. Right, let's try and do it. In fact, I should come back out of this and press the right thing. Hold on, I'm a little bit befuddled today. Object management, play. All right, let's see. Yeah, so as it says there, up till now we've been handling, multiple objects in your games, but only a small number of them. So, 2 paddles and a ball, or the brick wall, special case object. But it's all been fairly simple, and we've done the horrible thing of we've created most of our game objects as global variables that we just create, initialize them early on and refer to them with G underbars everywhere, which, as I've said to you, is kind of a reminder to us all that they are ugly global variables and that this is not an ideal situation. It's just the easiest thing to do when you get started. And in a small project, it doesn't matter that much. You've seen it's been fairly convenient. You can just refer to G underbar paddle, G underbar ball. You can talk to them anywhere, do what you need to do. It's simple, but it's ugly. And it's not good at scale. Imagine if you had, multiple balls, or just a general diversity of entities. You don't want a global variable for each thing. It would become extremely obviously tedious, and already it's a bit unattractive. Okay, so this is bad. It's clumsy, it's error prone, and the other problem with global variables is that generally speaking, when you write like a function or something, the ideal case is that a function or a method would just, you could tell from its inputs what it depends on. You would say it depends on these inputs and it does some computation and it produces these outputs. And it's kind of, when that works, it's very clean. You can say, you can see how the data flows through. If you use global variables, all of that goes away because global variables are just magic. They're ambiently available everywhere. So every function in the system could potentially be mucking about with gball. So you could have like some function you don't know anything about, written by another person on the project, could be tinkering with your global variables in a way that is basically invisible unless you do that line-by-line code inspection, which is really horrible, right? So that's one of the bad things about global variables is they totally break any idea of like data flow, dependency, the ability to see where things are happening, because instead of passing information as parameters, which is the clean way to do it, you basically have a bunch of secret magic underground tunnels where every function is connected to every global variable, and that could affect any other function, and the whole thing just becomes like a nasty mess. So you want to avoid it. This is most obvious as the number of things increases, so it becomes a scalability issue, and things that don't scale are the kind of things that go wrong on big projects when you're doing something at real complexity. All this kind of stuff, you can get away with it for a while, but eventually it catches up with you and makes things so messy and intractable that you can't figure out what you're doing, and nothing ever works, and things are breaking for random reasons. These are things that you want to avoid. Obviously, real modern games have got hundreds or thousands of entities in them. They're definitely not doing them with global variables. But I think you can probably already guess what we do to solve that problem, because we basically hinted at it with the breakout exercise. What you need to do is generalize across all the operations that you want to perform on your game entities, and provide some kind of more organized, centralized way of handling them. So breakout, we did that a little bit. Remember, I kept telling you, don't create 30 brick objects, create one wall object, and part of the wall's job, in fact, almost all of the wall's job, is to do kind of management of these inner entities that are inside it. So the wall serves as a container object for the bricks, and in a sense, a kind of manager object for them as well. And this is what you do. This is how you scale things up. So in the case of the wall, it didn't have much to do because the bricks themselves are rather inert. The bricks don't move or anything like that. But in a real game, you'd be managing a bunch of objects that do move. So maybe a bit more like Space Invaders, where you still have some kind of collective entity that's managing the invader wave, but they do move and they maybe animate independently. There's a version of Space Invaders called Galaxians. Does anyone know about Galaxians? No, it's just a sort of version of Space Invaders where some of the invaders can fly out of the formation and come and attack you. So they're kind of independent of the main horde. And that's something where the object has got quite a lot of independent behavior, but you'd still want to manage it as part of an overall collective. And that's what I'm getting at today. So the answer to this is you have an entity manager in your game that basically looks after the creation of the things that would otherwise have been global variables. So what an entity manager does is it lets you kind of create entities on demand, so you can create them at runtime instead of just having to, with global variables, you kind of create them at startup implicitly, and you can only create them, once. Obviously, real entities, you want to create them at runtime and then delete them and recycle them. So an entity manager lets you do that kind of thing. And then once you've created them, it also handles looking after them so that they get updated and rendered. Because remember just now, whenever you add a new object to your current exercises, you have to create the global variable, write the code for it, and then you have to go down into update simulation and add a line that says, thing.update, and you have to go into the render with thing.render. The idea is with a manager object, you don't have to do that. You tell the manager to do the update and the render, and it looks after everything and just does it automatically. This management becomes important later on, because you're going to want to do things like, say, when you're doing collision detection, you might want to say, where are all the objects that are near this place? And it's like, well, how do you do that? The dumb way would be to have a list of all the objects in your game and iterate through them to see, am I near any of these? And that's terrible. What you actually do is you say to the entity manager, could you tell me all the things that are near me? And it kind of knows, because it's its job to know. So just now, we're having to do ugliness like this, which I inflicted upon you, where we're doing the old ship update thing from the exercise. Now, the fact that this has been done twice and 4 times is a bit of an exception. That's because we were checking how the time things work. But basically the point is, I've got a ship and I'm having to call update, I've got another ship and I'm having to call update, and so on. And that's rubbish. What we want instead is something more like this, where you just say, so the process diagnostics was there previously, that's just like all the generic stuff, it doesn't matter. And all the update logic just collapses to one thing. You just say, hey, entity manager, update all the things. And that then does what it needs to do. Now that's a little bit of something called programming by wishful thinking here, where I say it would be nice if I could just say update manager update. That's what I would want it to do. And sometimes when you design an API, that's what you do. You say, well, what would I like to be able to do? And you do it. And then, having had your wishful thinking, you actually have to implement the damn thing. But it's not hard. It turns out that what the entity manager is doing is it's just looking after an array of objects, just like when you were creating, trails on the balls or things like that, for those of you who did. So you just get this. The entity manager update routine is a fairly simple thing. That in this example here, it just loops through an entities array and updates each one. There are some little details here I'll just mention it for completeness. I've got a couple of naming conventions that are going on here. One is that I've put the little letter A in front of entities. That's a thing that I often do just to let me know that something is an array. So this is a convention sometimes called Hungarian Notation. Do you know that term? There's a guy from Microsoft called in the olden days called Charles Simonyi, who was Hungarian, and he was fond of doing this on his APIs, where he would encode a little bit of type information on the front of a variable name. So, for example, if a number was a floating point number, he'd call it, F something. Or if it was a zero terminated string, he'd put S0, meaning string zero terminated. So if you look at Microsoft APIs, you'll often see they've got these little weird, daft random letters at the front, and they're known as Hungarian notation. So opinion differs as to whether it's a good idea or not. Some people like it and some people don't. But I think used in moderation, it can be helpful. What it's doing here is it's just giving me a little reminder that whenever I see entities that, oh yeah, it's an array, it's not some other data structure that I might have, it's not a single object, I know that it's an array. So that's what the A is telling me. And the underbar in front of it, does anyone know what the underbar prefix is sort of indicating here? It's not something you've ever seen or heard about. You have an idea?
I think it's because you want to compare private.
Correct. So the answer was it's because it's private. So this is a convention that's used in the language Python quite a lot. So Python doesn't have real private member variables. Like JavaScript, it's got a very open object model where you can just tinker with objects all the time. But originally, when object orientation was being invented, the idea was that you would be able to say that some of your member variables were private so that you couldn't, muck about with them outside of special functions. So you'll know that, well, Java has that and C++ has it, right? But some of these other languages, they don't actually have any language mechanism for making things private, which is an interesting design decision. So the convention that Python uses is if you've got something that, you kind of want it to be private, which is to say your own member functions will manipulate it, but you don't want your users mucking about with it. The convention is you put a little underscore on the front of it to just say, treat it as if it were private, which is to say this is an implementation detail that I might want to change and I don't want you to depend on it, so don't use it. You're telling people outside your class to not use it. So that's what I mean here by so the entity manager has got a private variable that is an array of entities, and we just do a simple for loop through it, and we take each entity and we call the update routine. So this now means automatically if you add new entities to the system, they'll get their update called just by virtue of being in the array. Which raises the question, how do you get stuff into the array? That's also easy, as luck would have it. Instead of having this kind of thing, this is how we created the ship in the previous exercise. Said new ship, and then use this little curly bracket thing to create the descriptor information. So we just doing a new operation. Instead of doing that, which created a global variable, remember, we do this. Very simple. We just say to the entity manager, I would please generate a ship for me, and you give it exactly the same information. But what you're doing here is you're saying to the entity manager, don't create a global, just create this variable, stick it inside your array, and look after it for me. And that's easy to do, right? The implementation for that is trivially simple. So the generate ship routine just takes in the descriptor, just the way the constructor function used to do. And what you do, in fact, you do call you use the new thing on the constructor to build the object. But instead of it being a global variable, what you do is you push it onto the back of the corresponding array, the entities array. So this is very simple. So now it's nicely wrapped up. The entity manager knows how to generate ships. It turns out there's an implementation detail where it creates a thing and it sticks it in an array. But that's its business, and that's how it works. And once you've done this, you now have the freedom that you can support as many ships as you want. When you create them, you just get them. And that will allow you to create new ships on demand at runtime, which is nice. One way of doing this would be in your general update logic. You might have something like this. You check for the generate ship key, whatever it might be, and if you detect that key, then you call the generate ship function, and you're done. Again, why is it eat key here rather than just checking the keys array? Remember what eat key does? It checks whether a key is pressed and then it clears that key. Why is that important here?
So you don't spawn too many ships?
So I don't spawn too many ships, right? If I didn't do eat key here, if I just did G underbar keys, key gen ship, then it would generate a new ship every time that key was held down. But that would be on every frame that key was held down. So if I pressed the key, it would end up generating, well, if I held the key down for a second, it would generate 60 ships. Right? That would be too many. And actually, this is an amazingly common type of bug in real games. Not something quite as stupid as this, but it's very easy to end up creating multiple instances of a thing by mistake, and it can be quite hard to detect it. Imagine if I'd done this, if I hadn't done the eat key thing, and I had pressed the key to generate a ship, and I held the key down for a while and it generated 10 ships or something, right? The thing is, they'd all be generated in the same place, with the same initial value. They'd all get drawn on top of each other, and they've all got the same logic. So they'd all end up doing exactly the same thing. And you'd actually have 10 ship instances all flying about, and you wouldn't really see it because they're all identical to each other. Maybe eventually something would show up, but the horrible thing is, it's quite easy to create redundant objects, and you won't know until you notice things like it's going far too slowly, right? So this is a common thing to check for if you're ever writing something. Make sure you don't accidentally create multiple instances of a thing, because they can remain hidden for a remarkably long time, unless you do something like drawing them with transparency or something, so you can kind of see through them. Strangely common error, and it causes stupid inefficiency problems. Where that routine that's supposed to be creating some new entity ends up just creating tons of them on top of each other and just kills your performance. So watch out for that. So I've indicated here that if you do all this, you can have a little dynamic key thing that creates new ships. We do in fact have that. I've got it over here. So this is kind of like what you were supposed to do for the last exercise, the 3 basic ships that behave in the way they behave. I've now got the ability to come along, and if I press the key 1, it will just spawn a new ship in the entity manager, like that. Create one here, 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 here. I can create lots of them. I can create some arbitrary shape. And then they all fly. They're all real, right? So they're flying around doing what they're supposed to do. In fact, I can put the trail on so we can see how hideous that looks, and switch it off again. Switch gravity on, hell with it. Boom, there we go. So now we've got lots and lots of ships. I can reset them as well, reset them to their initial positions, and they fall down again. Okay, gravity off, reset, there we go. So that's the kind of thing you can do. So this is progress, right? We've generalized the system, we can do fancier things. But in a realistic game, we wouldn't just have one type of thing, we wouldn't just have ships. You would have arbitrary other types of entity. So the question might arise, how do you deal with them? Like imagine you have a city game and you're going to have cars in it and pedestrians and bits of street debris and all these kind of things. You could create a manager for each of those categories of thing. So you could do generate street rubbish, generate pedestrian, but you can kind of see that there'd be a lot of similarity there. It feels like you'd be sort of repeating yourself. So what I would suggest is, rather than having managers for each category, you have one manager that wraps them all. But you do still want to have the distinction. Sometimes you do care about different categories of object. You might find that you want to just iterate through all the pedestrians and not every object in the game. So you would still want to put the pedestrians in a kind of separate place to the other things. And what I'm going to suggest is you put them in a separate array. So you have an array for the pedestrians, an array for the cars, an array for any other important category of object, so that you can look at them sort of in isolation, but you can also tell the entity manager to just go over all of them when you want to draw everything. Okay, so the way you implement that is an array of arrays. So you can create an array for each big category, I'm calling them, of entities. That's like a bunch of related types. You could say like vehicles might be a category, and that would contain different types of vehicle. It might contain different brands of car. It might even include motorbikes. They might still be in the vehicle category if you choose to. So you have a category, and and you put those in the entity manager. So now the entity manager becomes a nested array, a bit like the way the wall and breakout was a nested array, although this is a bit more general than that. So the idea here is that we have an internal thing called categories. Actually, if I was being consistent, I would have called that A categories, but I forgot. So you have the array of the categories, and inside each one of those, you have an individual category, right? So this array contains another array called a category, and then inside the category, you go through and you pull out the individual member, and you call that. Do you understand that? Just a simple nested loop. Go through the categories, go through the instances, and you're done. So if you do that, you can now add extra categories to your system and still have the kind of fairly sensible organization of them. It would let you do things like saying you could add a bullet type to your game, and you have a bullet category, and that would be that. Or you could maybe add some rocks. These are hypothetical examples, obviously. So you can do things like that. And then once you've got these categories set up, you can also control the rendering of them. One thing that's sometimes useful when it comes to this is that you might have like a relative ordering between the categories. You might say that you want the rocks to always be drawn before the spaceships. If you have the category system, it's easy to do that. You just write your loop to make sure that the rock category comes first, and that way you can control the relative drawing of different categories of object. Which brings me on to your homework. Your homework this week, which we've got to a little earlier than usual, is to add bullets and rocks to your spaceship thing, which is the next step forward towards, well, you all know what it's going towards, right? And I want you to do some more things with it. Not just create the bullets and rocks, but when you create the bullets, they have a lifespan. They survive for like about, let's say, 3 seconds of game time, and then they fade out. Otherwise, they would clutter up the screen if you had too many of them. And for the rocks, let's just create 4 rocks to begin with just now, and create them with a random linear and angular velocity within a sensible range. I'll explain that, and that's explained in more detail in the exercise, but what I mean there is that when you create the rocks, you want to give them a random velocity, but the naive thing to do would be say, well, give them a random x velocity and then a random y velocity, right? But if you just did that, it would mean that some of them would kind of have like high horizontal velocities and high vertical velocities, so they'd move very fast on the diagonals, and the ones on the horizontals would only move slowly. So you see the speed that they would go at would kind of depend on the direction they were pointing in. And you don't want that, right? You want to have 2 things. You want to say, pick a direction and then pick a speed. So that's the way you need to do it in this exercise. You actually randomly pick an angle and then randomly pick a speed and then kind of fire it off at that speed and that direction. And that way they all seem consistent with each other. Oh yes, and allow the ships to be dragged around with the mouse. In the previous exercise, when you click the mouse, your main ship would follow it. And that was easy because your mouse handler would just have a G underbar ship, and you would just hack in the coordinates, right? But we don't have a G underbar ship anymore because we're not being hacky, and we don't want it to be only one of the ships. What we want to do is we want you to be able to drag around any ship. So what you need to do is when you click the mouse, you need to find out which ship is nearest to the mouse and drag that one so you can manipulate them, and that's a job for the entity manager. That's the kind of thing they can do. So you need to do a kind of thing that picks the nearest ship. So I will give you a brief demo of that, just so you know what I'm talking about. So the idea is you have all this kind of stuff here. I'll maybe reset that so it's a bit cleaner. So I'll just create another couple of ships like that. I can spin them around, fly them and stuff. And if I press space, they'll fire a bullet, and they'll all fire at the same time, just for convenience, for easiness. And you can see the bullets fly, and they wrap around the screen a little bit when they have to, and then they fade out eventually, and they fire in whatever direction you're pointing. So if you go like that, you can do that, and if you kind of go crazy, you can do shit like this, and it all gets a bit intense, and it's lots of entities, and eventually they fade out and they die and they get cleaned up. And you fly around and do stuff. Oh, I also mentioned there were rocks. The rocks are already there, but I'm just not rendering them. There's a toggle key on 0 that toggles the rocks and lets me see them, and you can see they're flying around fairly serenely. You'll also notice something, which is that they're not crashing into the ships. That's because we haven't got any collision detection yet, and that's because we're doing collision detection next week. But for now, you get this. So you've got the ships and the bullets and the rocks. So you've got, it's nearly the game Asteroids, except for the bit where you actually can shoot stuff, right? So that's what you're required to do this week. Oh, and I mentioned the ship, the picking thing. If I just click the mouse here, it drags around that ship because it's nearest, and that one there, and that one there, whatever happens to be close. There's a subtlety here, which I'll maybe mention again, just so you know. But if I take this guy and I put him here, take this guy and put him here. So it's kind of obvious that, if I click here, so we'll call that ship 1, 2, 3. If I click here, which ship should it pull towards the mouse? 3. Right, easy. Okay. If I go over here, which ship should it pull?
1.
Yeah, 1, right? Because we're in a wraparound universe, so although it kind of looks like he's close, if you bear in mind the distance around the whole universe, it's actually easier to get round to 1. So when I do that, the one from the left will jump across. And that's not entirely obvious, because if you just use naive pixel coordinates, he seems to be further away, but he's not. I can maybe give you hints about this on Wednesday, but the trick on the way it works in a wraparound universe is that it's a bit like on the Earth. If anything is more than a half of the radius of the Earth away from you, it actually becomes closer to you again, right? So when you're calculating the distances, if the distance is kind of beyond half of the wraparound of your world, you actually kind of negate it. So the thing that's 300 pixels away is actually 200 pixels away, if you see what I mean. And that's something you have to do when you're computing these little picking routines, so that it does the right thing and can pick things across the edges. Alrighty? Right. Oh yes, tip if you're doing this, don't put gravity on the bullets. This is something I saw. Somebody was creating a little 3D demo with a Unity or something or other, and I think the entities by default have got gravity on them. So this is what happened when this person tried to fire a bullet from their little spaceship. Clunk. Can you see that again? Clunk. This is the kind of thing that can happen if you're using like a class hierarchy system, because it might well be that your base class maybe had gravity on it, because most things probably do respond to gravity, but the problem would be there if you inherited from that to create a little bullet object, and it kind of inadvertently inherited the gravity behavior and had like a high default. Actually, the math doesn't matter, but it inherited that behavior and it was running it. So obviously what you'd need to do there in that case is you'd either remove gravity from the base class and you'd restructure, or you'd have an opt-out where the subclass would say, actually, no, I don't want gravity, put a flag in to disable it. So in this case, this won't really matter for us, because we don't have a big class hierarchy. So as long as you don't try and put gravity on your bullets, they shouldn't have it. Right. The other relevant thing about this exercise is that we were able to create those ships and the bullets, but you saw that the bullets eventually they died, and something has to happen, when they get killed. So we need to have the ability to kill objects now. In fact, I can also kill the spaceships, as it turns out. If I go and press K when I'm pausing over a spaceship, I can delete them as well. So we've got like the full set. We can create things, and we can delete things to our heart's content. So, to be or not to be, we need to deal with the fact that our entities might die. And there are a couple approaches to that. I'm going to suggest one that I think we should use for this exercise. If you think about it in a kind of object-oriented way, this idea that it's the job of an object to work out its own fate, to work out where it's going to be on the next frame and all that, I would say it's also the job of an object to work out whether it's time for it to die. So if it does like it does the bullets do the timeout check, they have a thing that measures how long they've been alive for, and on every update you subtract du from that number until it starts off as being 3 times 60 to mean 3 seconds worth, right? 3 seconds worth, and you subtract du until eventually, if it becomes below 0, it's time for that entity to die. So the question is, how does the entity tell the rest of the world? How does it tell the entity manager that it's dead? What I'm going to suggest is that you make your update routine return a value, just a true-false value, that says whether or not the entity survived that update. If it survived, it's fine, don't worry about it. If it didn't survive, it returns false, and then the entity manager says, okay, you didn't survive your update, I now need to clean you up and get you out of the system. So rather than just doing true and false, which you could do, but the problem with true and false is you look at it and you think, well, okay, what's true, what's false? So what I've done is created a little boolean called kill me now, which it just is, is set. It will be either defined to false or true. I can't remember which one I picked. But the point is you just create this like a meaningful constant, right? And the idea is that when you finish your update loop, if you want to die, you just return entity manager.kill me now, and then you pass the problem on to the next guy, and the entity manager figures out how to get rid of you. And what does the entity manager do? Well, again, it's a bit like the thing we saw. We had to do some of this for breakout, potentially. You splice things out of the array, which is where you just say this position in the array, remove this thing, and shuffle all the others back up to compress it out. Right? So if you do all this, and you've got like the update of a bullet, and it realizes that its time to live has gone below 0, it returns kill me now. The entity manager says, okay, I'll splice you out of my array. Remembering that when you splice from an array, you have to be careful not to do the skip thing. Remember that thing when you splice, you have to like make sure you don't accidentally jump over the next guy. So you have to handle that here, right? You splice out of the array, and then what, right? You've removed the object from the array, but has it really gone from the system when you do that? Do you know? Well, what happens is that if you remove it from the array in a language like JavaScript, which is garbage collected, what happens is you haven't really deleted it yet. You've just unhooked it. You've just said, look, the entity manager doesn't have a reference to it anymore, but it won't actually get deleted or free up memory until the garbage collector says it's time to remove it. So you must know about garbage collectors, I take it. Right? So this is an interesting subtlety and kind of important in games. A lot of game developers are wary of garbage collection because as a process, it kind of runs in the background slightly unpredictably, and it can sometimes take time. One of the things that you used to see the Unreal Engine does use garbage collection, but you sometimes notice when you're playing Unreal games that they hitch a little bit from time to time, if you're unlucky, and that's sometimes the garbage collector kicking in. That's where every so often the system has to go around and find all the objects that have been detached and actually free the memory from them. I had to do a lot of work on one of my previous games to make that more efficient, because by default, like every 30 seconds, the engine runs a garbage collection pass. But if you've created a lot of garbage, it can take a lot of time to find those objects, and you get a kind of a stutter. What other game developers do if they're working in like plain C or even C++, is they manage the memory deallocation themselves. So when they get rid of an object, they don't just remove it from the entity manager. They actually explicitly call delete on it, and they actually claim the memory, right? But there's a downside to that. The problem is if you just take an object that you think you don't need anymore and you delete it, the problem is there might still be other objects that are referring to it. So the other problem you can get in a game is you might have like some pickup object or something, or some piece of junk in the world that you shoot it and it dies and you reclaim it. The problem is if the object that you're destroying, if someone else is holding a pointer to it, like for example, maybe if 2 people had targeted it and one of them kills it, then you might say, well, okay, delete this object and free up the memory. But you've got this other guy who had it in his targeting system, so somewhere over in this other object, there's a target variable that's pointing to this thing that you've just deleted. And if you've deleted it, it means that it's not valid memory anymore. So when he then goes and updates his targeting system, he's pointing to invalid memory. And this is the kind of thing that can cause a game to crash, like if you try and access invalid memory. So the good thing about garbage collected systems is that doesn't happen in them. In a garbage collected system, you unhook the object when you want to kill it, but if somebody else has still got references to it, they still do. So what you do is you mark the object as being dead. You kind of give it a flag that says, oh, by the way, I'm dead. So, please don't draw me and don't collide with me, but actually, I'm dead. And that means that other objects that are still referring to it can, and then over time, the assumption is that they will release those references. And when eventually no one's referring to it anymore, the system actually deletes it. And that's what garbage collection does. Whereas if you do explicit deletion, you have to be careful when you delete an object that there are no pointers to it anywhere else in the system, which can sometimes be a hard thing to do. It's like, how do I know that nobody else in the whole game has got a pointer to this object? It becomes a garbage collection problem, and you sort of end up writing your own garbage collector. So that's garbage collection. Is it worth me showing this to you? Not really. This is a bit of a stretch, but this is Arnold Schwarzenegger as a garbage collector. And I don't know if you've ever seen The Last Action Hero. It's kind of terrible, but there's a bit in it where they're doing a parody of Arnold Schwarzenegger as Hamlet. So if you wanted to know what it's like if Arnold Schwarzenegger played Hamlet, now you're going to find out.
Hey, Claudius. You killed my father. Big mistake.
Something is rotten in the state of Denmark. And Hamlet is taking out the trash.
Stay thy hand, fair prince.
Who said I'm fair?
No one's going to tell this sweet prince good night.
To be or not to be? Not to be.
Did some of you notice the Wilhelm scream at the start of that? When he threw the guy out the window, it's the classic scream sound that you hear on all the movies. Deliberate reference there. Anyway, so that's what happens when you return kill me now, kind of. You get garbage collected. Okay, so that's that part of it. The other thing that's relevant about the homework now is, in addition to the spaceship, we also have the rocks and actually the bullet, although I cheated with the bullet. But the point is you've got multiple sprites, and we said with sprites in web games you need to preload them, but there's a slight problem if you need to preload multiple sprites. It's a little bit ugly to do. Now, I did give you a taster of that last week, so you could use it for Breakout. I gave you the routine that does multiple sprite preloading, but it's necessary here, so it's part of the exercise this week. What you have to do is write a routine that loads a bunch of sprites and has a bunch of callbacks, and they all kind of interact until everything resolves. It's a pain to do it, so I did it for you, and I think I can just show you the code so you can sort of see what's going on. So this is this week's exercise. I'll give it to you. I've got it here on my website, but also I'll give it to you as a zip file, so it's easier to get started, just like I did with the Pong zip, right? So this has got the template that you're working from, which is kind of what we've seen before, except it's now called entities, right? But bear in mind that this one, when it starts, it's got nothing on it anymore. That's because what should be happening here is we should be rendering some stuff, and that's the entity manager's job. And it's your job to write the code that does that, right? But it's easy. You just copy it from the lecture notes. It's simple. I'll show you that part of it as well. So the entities thing, this is a description of what you need to do. I create some ships to begin with. You can see that the render part now just calls the entity manager. Let me see if I make it a bit bigger. It just calls the entity manager to do the rendering. If you go and look at the entity manager itself, there's a bit in here, so it's got things like this, find nearest ship, that you need to do the picking, you need to figure that out, and there's a bit in here where it needs to do the rendering, and I haven't done it, right? But it's simple, so that's why you don't see anything, because there's no rendering yet. But the thing I wanted to show you was the preloading. The way that works is that the main routine has got something, or maybe it wasn't the main, there was something else that kicked it off, doesn't matter, the entities bit. Was it entities? Yeah, the entities bit, there's a little preload request where we just kick off the game, and what I've done is I now require a ship and a rock, so I put in the URLs for those things, and then I call my preload routine to make it all happen. And either, as you say, I want these images, put them into this array, and when it's all done, call this thing that lets me know that it's done. And the preload done routine can now say, well, it's definitely, the things have loaded, so I can now create sprites based on those images. So I can create a sprite based on the ship, and that will be my ship sprite. And I can create one based on the rock, and that's my rock sprite. And I can create one for the bullet, which rather shockingly is also based on the ship, just shrunk down to quarter size. I don't know if you'd noticed that when we were playing it, but the bullet is just a tiny, tiny ship. So I didn't have to bother drawing or finding a bullet. And it spins, it's got a fast rotation, so you don't really notice, but it kind of makes sense, doesn't it? There's a kind of fractal unity to it, that the ship, maybe the bullets would fire out even tinier ships. So I set these things up, and then you can actually call the main routine. So the magic of the preload, you don't need to know the details of it, but just to give you some idea of what it actually has to do, it's kind of horrible. You can see that there's a preload function here. It's got a handler function inside it, a nested function, and then I do this thing where I iterate through the images that you request, kicking off an image constructor and an asynchronous load for each one. And each one of them has a handler function, which is this guy up here, and it just has to kind of wait for all the images to come in. And what it does is it counts them until they've all arrived, because they could arrive in any order. You don't know, and so you don't know which one's last. You don't know which one to wait for, if to wait for them all. So this just waits for them to all arrive, and when eventually it's done, it tells you. And there's some diagnostics here to let you see, just in case it doesn't work. For example, the problem here is if one of these images is missing, this routine never terminates, and your game won't start. So if those images went down, it would die, which is not great, but that's just the way it is. I'd need to add some other thing where there's like a timeout and an error message that said couldn't find images. I didn't do that. So that's the mechanics of that rather ugly routine that's going on in the background. Okay, and that is what I have to tell you about that. Any questions maybe that are arising about that implied homework exercise?
Could you use the image preloader to preload the music as well?
I think you could, yes. I think you could use the image preloader to preload audio assets if you wanted, because unfortunately, it actually has some code in it that does new image, so it's not quite right. I guess you'd need to have like a flag to tell it to do new image or new audio, or you could create an audio preloader that was sort of the same, but that'd be copy and paste. It's a good question. I think ideally what you would do is make it an asset preloader, where you'd have the name of the asset file and then a flag that says whether it's an image or a sound, so that it knew which constructor to call, and you could maybe preload a bunch of stuff that way. It's a good question. Okay. Anything else? All right, I'll stop it there.